x1, okay, is ending up with x1 in his hand, and then another policeman, let's call them like policeman 1, P1, and this P2. Then the second policeman said, he called him and said, you know what? Now you're going to give me half of what you have now, whatever left, plus one more apple. And then again, the story goes back and gets to the third policeman, and the policeman tells him, you know what? You're going to give me half of whatever left plus one apple. And then the guy, poor things, ended up with only one apple in his hand. And I said, guys, give you a little hint on how I'm going to solve. Let's say this is, let's call this one x3. Okay, if I want to know how many apples did the boy had before he met, just when he met the third policeman? So I can go backward. Backward solving, it's really an easy, and you'll see it becomes to be very simple. He had one apple. The policeman took one, okay, before he took the half. So before the half, he had two in his hand, okay, because I took this one plus the last one, and then you have to multiply it by 2. Let's do it. Multiply this one by 2. And now if you do that, you'll see. So how many I have here? I have this one. Multiply by 2. Okay. So in fact, the truth of the matter, let me copy this one. Cut, I put it here. And so think about it. Before he met the third policeman, the policeman took half of it, which is, it would be left with 2. After he took the half, he took 1, he end up with 1. Now going backward, you do the steps backward. If he ended up with 1, the last action from the police is taking 1. So if I give it back to him, we'll have 2. But the policeman took half, meaning the 2 that he has in his hand has to be 4 before it, because he took half 4. Now the trick will be, going back to this one becomes to be very simple. But what we're going to do now, we're going to take this 4. We're going to add 1. And all of it, we're going to multiply by 2. It becomes to be very simple. Okay, so he probably had here 10. Now, by the way, the same things, it will be the same. In fact, I can even copy this one probably. I try to keep the distance the same. It will be just copy to there. It should be really the same as 22. Now, because the logic is the same logic, okay? You're just taking whatever he had right before he met the second policeman, you add back the 1, and you multiply by 2. Now, if you go back and you can see, 22, half of it, it's 11. Minus 1, it will be 10. So this is exactly the 10 here. You take half of it, it's 5. You reduce 1, you'll get the 4. On the 4, you divide by 2 again. Half of it, you have 2 minus 1, you get the 1 what the boy had. So meaning some problems, it's easier to solve them by going backward. Now, what it has to do is the area, it's already the same, but the analogy is quite close, okay? We're trying to know, let's say I'm here in this point, okay? Let's say I'm in this point, okay? And I don't really know, should I go to the right? Should I go to the down? Should I go back? Maybe I was wrong. Or if I'm going here, it's very clear. I have a wall. But eventually, my decision in this point is really eventually going to be affected by the path I'm going to end up in the end, okay? And by kind of, to some extent, you will see as we dive into the algorithm, how it does it, you are really eventually you're gonna go like kind of, if I know the value of it here, I'm gonna know the value of that here. And the value here is gonna be depend on this one. And this one is gonna be depend on this one. And going backward all the way until you, by the way, this one, okay, depends on this one, okay? And this one will depends on this one, etc. It will go all the way back until you get to this point. And then really this point, it's like depends all the way to the end result. It's very similar to the story of the policeman and the boy. But this one, it's a little complex, okay? And we're going to solve it in what is known as a Q table. And I'm going to dive a little bit. I will throw a lot of concept and I will go again on what we did last week. And I will do it again next week. And if we need, and you guys will ask me, I will do even one extra week because it's so important, development of the way of thinking. And let's see what's going on here. We have an environment. The environment, it really is this kind of 10 by 10 kind of picture here. And this 10 by 10 have several, we have really 100 boxes here inside 10 by 10. It's 100 boxes. This is the environment. Now, the agent is the guy that's trying to walk from here to here. So he's interacting with the environment. And I said this game is like you're giving a guy and you're closing his eyes, or a girl and you close her eyes, and she doesn't know where she's going. She just, at the beginning especially, she will start trying to go randomly because she doesn't know where she wants to go. She's in this point, but she doesn't know. She might go backward and she will hit a wall and she'll get out of the game. And then the environment will tell her, hey, you can go out. You're getting out of the game. So she will get a signal from the environment. If the agent, the agent, she's taking some action. And the action she takes, it's where to go. She can go to the right. She can go up, and then she won't be able to go anywhere. And then the environment will give her a signal, oh, you can go back, and you put her back to the same spot. She tried to go to the left, the environment will say, no, don't go to the left. Okay, go back. And then if she go down, the environment will say, oh, you have a wall here. And then she can go to the right. Now, when she goes to the right, oh, she's happy. And in fact, we will see the environment tell her, okay, yeah, you can go to the right. That's what the state ST plus 1. In the beginning, the agent is the state S or ST, the first one she's starting, time T. And then when she takes an action and make to the right, she will be happy because she will get a signal, yes, you can go to the right. That will be her new stage. So she will be on the right. And then tell you know what, good. I give you a reward. That will be a signal how good you did, okay, by going to the right. Usually in reinforcement, not really always, but most of the cases, the reward will be a positive number. And this example we will see will give a negative reward. And there's a reason, because we're trying to find the shortest path. Then we'll see why this should be negative. Because if we didn't give a negative number, the agent, she would try to go in the longest path. And she would never get here. She would just run around because she would try to get more reward, okay? And her goal is to get from this point to this point in the less negative reward. In other words, she tried to go into as less, like this point, she has no reason to visit this point. There's no point, she can go anywhere from this point. And so she would try to minimize making unnecessary step by giving her a negative reward. And then we'll see how that's accumulated, okay? It's really hard, honestly, okay? I'm aware to how hard it is for some people that it's their first time studying these kind of things. A lot of that doesn't make sense first time you hear it, but take my word for it. You'll do it enough times, all of a sudden it will make a lot of sense. And this is just the beginning. I'm going to continue and give you more concept that it's hard to swallow first round. That's why I will go over it several times in different ways, and eventually it will be clear. And then we'll build on top of it the neural network. For now, we'll go step by step, understand this kind of logic, how to solve those errors, okay? So we have interactions between the agent and the environment. In other words, this person walking here is doing an action, it takes an action. The environment gives a signal to the agent, okay? Can he go there? And a second, what is his reward? So every time he goes to a place, he will get a negative sum number, okay? His objective is to get to here. And he said to himself, you know what? I'm trying to minimize the penalty I'm getting, okay? That's really his. So if every time I go, you know, let's say he's going first time, let's go another concept. You know, the person is closed eyes. He has to have a memory. And he has to keep that memory somehow, somewhere. So we'll talk about Q table in which you will put his memory. Okay, so he's going and playing the game because the first time he tried to walk, he might stumble around here and then eventually make it to the right. You say, oh, good, I can make it to the right. So that another word you can say, this block, this little block, it's more valuable to me than this block because this block doesn't take me anywhere. Getting out of the game, I'm definitely in trouble. So this box has to have a value higher than the one surrounding my first point. In other words, although this might be negative, okay, as we will see, and eventually it might be positive. We'll see why everything will turn eventually to positive just because the end one will give a big reward. But let's go slow on that. One thing is clear. This square is the best square out of all the one surrounding the beginning point. Okay? And the agent has to remember that. The way he will remember it, it will document it, and we will document it in a Q table. Okay? Then he gets to this point, and now what is the next one? It goes down, he says, well, it gets blocked. So you know, this is a bad box. So I'm gonna give it a negative number. So next time I will try not to go there. One thing it does have an access to. It can read what is in the Q table, where it's documenting the result. So based on that, in the future, it take an action. So if he stumble here, most likely for next time when he's in this point, he's not going to try that again. Okay, it will go to the right probably because this box is better than this one. Okay, so this one better than this one. So it probably will go here because this one should have a better positive number. In the very end, you will see, you will start accumulating experience. If he is here and he tried by mistake going to here, he will document to himself, this is a wall. This is also not a good box to go again next time. So we're going to play the game, the agent going to play and move from one point to another, trying to do an attempt, going to this one. It is, oh, it's a wall, I shouldn't go there. He documented, and then eventually from here, he's going to here. And this one, it must be better than this one or this one, and he has to document it. How does it document it? It documents it in a Q table. I'm going to do one more thing to really expand your way of thinking. And first of all, what is a function? By the way, here we're using a Q table in this example. But as we see in the future, in this example, we will utilize a neural network to estimate a function. It doesn't make sense, whatever I said just now, but believe me, it will as we go along, and you will see. So here, we're going to use a Q table. What is a Q table? Just think about it. We have all those states. How many states do we have? We have 100 states. Every little box, it's a state, okay? It's a situation. I might be in this situation. I might be here. I might be here. Each one of them, it's a situation. So I can make a table with numbers from 1 up to 100. Okay. In fact, the computer does it. You will see. We just exert the code will do it. But it really would be nice. Okay. And in every cube we are, there is 4 actions we can do. four actions. By the way, in the computer, we usually really use 0 to 99 in Python, JavaScript, and many programming language. You will use index, usually numbers. You start from the 0. It looks odd in the beginning, but take my word for it. It does make sense. The more you get experience, you see this is a good way of numbering it. It's from 0 to 99, it's 100. Something says here. 0, 1, 2, 3. Okay. Now, these are four actions that I can do. And what are those four actions we can take? The four actions, let's say, if I'm in the beginning, I can make a left, but then I'll get out of the game. I can go up, I can go down, or I can go right. So there's four actions that I can take. Okay. I can go, let's say, left. I can go up. I can go down, and I can go right. Fair enough? I hope let's make it bigger a little bit so you can see it better. Now, you know when I'm in the beginning, okay, I'm in state 0, in fact, you can think about 0. This might help you also the way it's when we look at the code, we're kind of numbering them several ways. 0, we're referring to the first box, this first box. You can look at that as index of 0 to 9 and 0 to 9, like the way you usually do, like your mathematical multiplication chart. You can number those ones 0 to 9, 0 to 9, and then this one could be the index of 0, 0. This is going to be 0, 0 index. Same things. It's just the way I want to number them. So 0, 0 mean the first box. I can call the first box number 0. I can name it. Then when I'm in box number 0, I can take one of those actions. One thing is clear, okay? Immediately to us, going up make no sense, making left make no sense, going down make no sense, and going to the right is the only one that makes sense. If I look now at all those four options, what's the value of every action to make? This one must be some negative number. That's just, I will write 100, but it's really not the right number. The computer will find the right number there. Let's say if it's 100, I'm just making up numbers. Yeah, this is not really the numbers. But here, if I have a positive 10, and now if I'm in box number 0 and I have to make a decision, I'm the agent. Which way should I go? I'm looking at this. This is the Q table, by the way. That's what we call Q table. I will go over that also in the code, okay? And I'm in box number 0, 0, or number was 0 that I called it. Which one should I choose? Definitely I will choose that one. We will see something called, okay? We will see something called ARG. It's a concept, max. I don't know how many of you are familiar with that concept, but what it means is out of all those four, give me the index of the place that give me the highest value. I will repeat. If I apply the function argmax on those four ones, I'm asking this function to do, look for the highest number. Oh, if this one is the highest. Don't give me the 10, give me the 3. So this function give me the value, okay? Give me the value 3. Now, if I do max of the same things, if I apply the function max on those four, it will give me the number 10. Everybody happy? Okay, we see the difference between argmax. By the way, I wish somebody explained it to me. These were when I was in school. And I never knew until I killed myself to understand the difference. Max function give me the highest number, and it's 10. And argmax give me the argument or the index of the one that give me the highest number. The highest number is 10, and the index is 3. That's why we're getting 3 here. We will use those two in a minute. You'll see in the code when we utilize it. So now the beautiful things eventually going to be the following. Now there's one more concept. I don't have 3 dimension here, but this is one thing that we need. You will see we have in every action that we take, okay, we will have to know if I'm going to the right, this is the best box to go to. But which box is number 3 is taking me to? So I can say, when I'm here, going to the right, I'm going to this box. So I need also some way to find out from this cell going to this cell, which index is this cell. By the way, this cell could be 0, 2, 0, 1, 0. This is 0, this is 0 and 1. And I can say the next one, it could be this one, 0, and going to the column 1. This will be my next one. So from this one, in fact, this is going to be my choice, because this is the best place to go. Okay? And that also means to which cell am I going? So this one might take me to this one, which is the 0, 1. Okay, here I would have to know the value of the next step I should go. So let's do that one more time. Try to do that. I'm now in this point. Okay, I'm here now. Which ways can I go? I can go up, I can go down, left. I won't go back because I'm going to the beginning. There's no point. Or going down. I might go by mistake left. Nothing have to stop me. But and in the beginning, the algorithm will see how it works. You will see that you might go back, but eventually, very fast you learn you don't really want to go back. There's no point. But you really want to go to the right. Which one is this one? Okay, this one could be 0, 0, 1, 2. It could be the next one. Let's say this one is a 0, 2. So that means if I go again to the right, let's say Max says this could be also. I'm just throwing numbers now, just negative ones. Minus 50. We'll see how those determine. The algorithm will do it for us. Minus 30. And let's say this one is also 10. Of course, I will go again to the right, because that's the only things make sense. What's happening now? If I'm starting the game, going right and right, I already know the good path. I already know going from here to here to here. And I'm really, that yellow will tell me the path until I will get to this point. I'll do one more. When I'm here, I really should go here. Fair enough? So what am I expecting eventually when this Q table will be built, and we'll see how it's being built, how those numbers are being calculated? I'm expecting that going down will be the best. I'm going to enumerate all the next ones. So let me do that. This is the first row. And I'm going to do the next one. Just really, it's a beautiful example for you guys. And try to, will be 1 and 0, okay? And then we'll have 1 and 1. Then we'll have 1 and 2. Sorry. This is a good first time seeing that. Spend the time understanding it. It's worth to go slowly. So by the way, I'm not going to use from this point, I'm not going to go to this one or this one. We know we're going to go to what? We're going to go to 1. This is 0, 1. 0, 1, 0, 1, 1 to 1, 2. This is the place we would like to go, to 1, 2. Now, if I look at 1, 2, which is this one, I would expect that from here, I'm going to go to this one. And I expect this one to have a higher number than the other one surrounding. So I'm expecting, let's say, put this one 10. Okay, so from here, I'm going to jump to here. And I want the algorithm eventually to find out that this is the base. So when I'm here, and I'm really moving to this cell. And from this cell, okay? It's which way should I go? When I'm here, really going down has to have the highest value. So for when I'm here in this one, going down should be the highest number relative to the other places. So let's say this will have me minus 28. I'm just making up numbers, minus 38. And this one should be a positive, and this one could be also minus 10, 20, I don't know. But one thing is clear. This one eventually will take me to this one. Okay, so let me, this one I think I'm going down or right. 1 sec. And when I'm here, I will go again down. So this one is wrong. This one is wrong. We have to see which one will do. Okay, but one thing's clear. This one should be the highest in this row. So when I'm in this state, in this box, I really should go down. I really shouldn't choose, not going up, not going to the left, and not going to the right. And eventually, this one, when I'm going down, is really taking me to this one. Now, when I'm here, which way should I go? Let's do one more, and then move to the algorithm itself. So when I'm in this cell, which is this cell, which one should I go? I should really go down again. So the going down should be the highest number again. So meaning here it's also should be a 10. Fair enough? And all of the other one probably would be negative or lower number. It could be number 1 or number 4, that as long as they're lower than this 10. Okay, let's say this is minus 56. I'm just making it up. Okay, the key point is that I know when I'm getting to this cell, I really should go down. Eventually, what is this Q table is? It really is a function. It's you can write, how do we write functions? We write a function with parameters. And what are the parameters here? I can write the row and the column. And what is the row? The row is the state, the box I'm in. So if I'm putting the box here and I'm putting the column in this case is the action I'm supposed to need the value. Fair enough? Everybody got it? So a table, in some sense, you can think about a table as a function with 2 parameters. One parameter is the state. It's the box I'm in, we call it a state. Okay? And the columns here is the actions that I can take. And there's 4 actions I can take: left, right, up, and down. Okay? And this function will give me the value inside the box. And we will see, we'll convert a table to a function in the next few sessions when we talk about neural network. And the neural network, the beauty about neural network, it knows how to estimate almost any function. And that's the beauty, and that's the most innovative about AI, artificial intelligence. It's beautiful. It really is beautiful. So we learned some concept. Let me repeat them. Max of a row give me the highest number in the row. Argmax gives me the index of the highest number. So here in our example, the 10 is in the 3rd place. That's why this function will return 3. Okay, one more thing we saw. The tables tell me which one I should use. I would choose the highest. And according to the index, I know that I'm supposed to go to the right, because going to the right will give me the highest value. And I continue from this one, I go to this cell. From this cell, what should I do now? Again, I should go right again. When I go right, I go to this cell. And this cell is this one. And then from this one, we know that I should go down. And that's one going down, take me to this cell. And that's when I'm here, I should go again to the highest one. And then again, when I'm here, I should go down. That gives you the way that eventually, you will see in the end of the exercise, there is a function called path. From the Q table, we can find out what are our steps that we find out to get to the end result. So those are just concepts. I didn't connect everything, and we'll dive into it big time. One thing which is really hard, and up to now it's reasonably, you can understand it, but I'm gonna go into another concept, which slightly hard, okay, for first time hearing it, and I will do it several times. I will say it now, and I will go over it at least 5 times, today and next time. How those numbers come about? How do I calculate them? I won't go into all the mathematics, but this is something known as a Bellman equation. I put some material for you guys, especially in here. This one is a good one. If you look at this article, okay, it gets into the theory a little bit, okay? I will jump about the DNQ, ignore the DNQ as much as the algorithm. And I want to talk about this one. By the way, you see here this concept called argmax. That's what I was talking about. The A is the actions I can take. And I said the table is like a function. And as I have the Q table, many times we call it as a Q, okay? And the S is the state that I'm in. So what this one try to say? That when I get to any state, okay, when I get to any state, okay, I will take the actions that give me the highest value. So if I'm in the beginning, I will take the actions right, because right give me the highest value. That's really what this function, this is just like writing it. And by the way, this is called policy. Policy means how do I behave? And the behavior is I always will go to the place that has the highest value. Okay, so that's one. Fine. This one is called optimal policy. What does it mean, optimal? Optimal in the sense I always pick up the best action that give me the highest value. Okay, that's one thing. But this is one thing that kind of we cover. But this is the heart of this study. This is really the heart of the algorithm. It's a little hard, but what does this one mean? Okay, and let me explain. It's a little hard to grasp. If you have a good eye, you'll see this part, it's exactly, okay, it's almost exactly as we have here. And not really, I wish they had one more step in this one. This QPy earlier referred to Q, and why do we have a Q? No, it's like a missing function here. Let me say that, okay? It's like the value of the Q when I am taking the best policy. What does it mean? Basically, when I'm in this state S pi, it means that I'm going to behave in the best action, okay? And then that's the policy I'm going to do. I'm going this state as pi, I'm going to take the best action. And when I take the best action in this point, that means this is the best A for this situation. This is the value of this state when I'm taking the best action. This is really confusing, very confusing, what I just said. But I will go again over it again, okay? What does it really mean? And then we'll go back to that again. I'm trying to find, let's say, what the value, how did I get 10 here? How is this 10 come about? We know that after I'm here, I will end up in this place. Fair enough? Let me do it on this example. If I'm in here and I know my next step going to end up that I'm here, okay? I said to myself, okay, I really should, when I'm here, my policy should be like the arc max. And that's going to give me action number 2, meaning go down. When I go down, the value of that place is 10, okay? And I'm learning what the value here as dependent on the value in the next step. Very similar like the policeman, okay? I know the value here based on the value in the beginning based on what the previous stages. If this is 4, this will be 10. If this is 10, this is going to be 22. Here, very similar. I said the value in this point depends on the value of the next step. But it's not going to be that simple. I'm going to calculate this one and I will change. By the way, the Q in the beginning has just random numbers and it will update itself. And how does it do the update? It takes this 10 and multiply it by some number between 0 to 1. Usually you take 0.9, but depends on the problem. That's 0.9. And then I'm adding the reward. Let's say the reward is 1, just for the example. How much is that becomes to be? Oh, it's done up to be. Let me try different numbers. Let's say the reward is 3, just for the example. Oh, I got number 12. That means the value here really shouldn't be 10. Depends on the next step. You know, after this one, the best action I should do, we know this one again. When I'm in this point, my best bet would be going down. When I'm going down, I'm ending up here. Oh, this situation has a value of 10. Based on this 10, this is probably have a different value. What is the value of this one depend on this one? The value of this one will be some percentage of this one, which in this example, I'm using 90%. We'll see, we'll call it usually gamma. I take the gamma, multiply it by this 10, and add the reward. The 3 is the reward. And bingo, I get to it. And then when we update the Q table, we're going to go here and change it to 12. That's what we're going to do. And now, by the way, when you know this is 12, you can calculate this one again. Is that right? By the way, if this is 12, you can go backward. This one leading me to this one. And by the way, if we do the sum calculation, since this is, I wrote it 10, it would be also 12. And in fact, if this is 12, okay, oh, now it will be, sorry, that's my mistake. Sorry, my mistake. If this is 12, how much this is going to be? We're going to do the same things. We're going to do the value of this cell times the 0.9 plus the 3 reward. Oh, now it's 13.8. Now what's going to happen to this one? We're going backward. You see that? And this one will be the same. I'm going to take this value now and multiply it by 0.9, and I will add the 3. Now the reward here is 14, even higher. Now you can see these ones are going to be higher and higher the more we get, and this will be much more distinguished in those ones. And that's automatically I will choose this one. Now it's very clear those ones are all positive. And by the way, if I go one more step, okay, it will be the same. We'll have higher numbers. And that's the way the Q table is updating itself until you play the game many times until you get the Q table totally filled. And let's do Q table, let you know how you should really solve this path. And then you will go just from this one to this one to this one, because you go only to the highest number. And going all of that, that's really what the algorithm. I intentionally gave you this article. It's a beautiful article. Really go read it. This is basically taking the best action, you get the highest value, you multiply it by gamma. This is a gamma. I just used the example of 0.9. And then you add the reward. This is the 3 in the example I gave. And that becomes to be the value. This is the Q table, the value of S when you take the action A. Pay attention. This is S, like in this example I did. Let's say I'm here. The value here depends on the value here times the gamma plus the reward will update that one to 12. And then if you go backward, you update backward. By the way, if you have, you want to do one more stage, guys, one more, what do you say? Anybody wants one more? Anyone? Nobody wants to do one more? Yeah, one more? Yeah, okay, I'll do one more, okay? One, okay, one more. Hey, let's say from here, if we go down, this is the 1, 2 stage, the 1, 2 stage, the 1, the 1, 2, we are here. What should we go? Going down. This one should really be negative or any small number. This should be small number. Going back, we know the number of this one now, by the way, don't we? Yeah, we know this number. Don't we know this number? Of course we do. We don't know we know the value of this one. We know also the value of this one, by the way. The value of this one is basically 12. We are now here and we have only 10. We know the next one to go, the highest one should be going to this one. This one is, by the way, is 2 by 2. So we need to really kind of continue those stuff here. Up to 9. Beautiful. And then we'll have the 2, 0. And then we'll have the 2, 1. And we'll have the 2, 2. I will stop here. Okay, so we are here. And really in this point, when we are here, that's the place we're going to end up. And when we are down here, by the way, where should we go? When we are here, okay, when we are here, we can go to the left or we can go to the right. We don't really know the value here yet. We don't know the value here, but going to the left will make the most sense here. So really when we are in this stage, going left makes the most sense. Making right could be also, it's possible. So let's say going left and going right should have some positive number. Going left, let's make left would have 15. I'm just making them up. By the way, they are being updated automatically later on. Going up, we know what the value of going up. Going up is really this value, isn't it? So I can even write 10 here, just for now. And this one going down probably would be 20. Okay, because I know the right thing is to go down. It should be 20 eventually. Although at the beginning, it will give me wrong answer, which fibble around, and then eventually we'll find it. And going to the right, okay, could be also, let's just write some positive number. Okay, the argmax in this situation probably will take me again to go down, which is also no, I think we should go left. My mistake. Going down should be negative number or small number. Let's make number 2 here. So the arg should be really give me 0. Go to the left. This really should be the highest. Because we know according to the picture here, this one should be the highest. I really should go here, not to here, not down, or don't go back. So this one probably should have a higher number than this one. Otherwise, I would go back. Okay, so again, so I will go to this part. So how is knowing that this 15, okay, going to affect, after I know that this is 15, this is going to affect the value of this one. How is it going to affect the value of this one? And again, this one could be, again, an equation. It's going to be the value of this one times 0.9 plus the reward. Bingo. 16.5. By the way, next round to the next one, and that one will update this one. So that 7 will pass that one. But this one will update this one to 16.5. I won't get into the whole things, but we'll go into the algorithm and see how the code is doing it. But basically, the beauty here, eventually, this table going into so many iterations, it being updated, that eventually, for every state, the highest number will be the right one that take me to the right stage. And that's really the logic of that one. That's one concept, Q table. And using, this is, by the way, known as the Bellman equation. If we would have time and maybe we'll do additional session, I might even get into that deeper. But this is really the foundation of reinforcement learning. If you study Bellman equation in mechanical engineering or in one of those, that's really one of the leading equation. The idea is that one step value depends on the future step percentage of that value plus some reward. And that's really what we're doing here. Okay? We'll get to that one. That's one. Now, one more concept. It will look like I'm contradicting myself, but I'm not. It's exploring versus exploiting. And let me go back again, remind you. I did all of that, but I really shouldn't start maybe this way. Let me take this one. How is this one start? Usually when you start it. Let me make it this way, just like here, as if the beginning. The beginning, you really don't have any numbers here. You know, you really don't have anything. So many times, what the algorithm does, it just puts zero everywhere. It puts just zero everywhere. And that's really what many times you use. The table, the Q table is all zero. And then you say, well, I don't really know where to go because there's no difference between any, sorry. Okay, everything is zero. So what is the maximum? There's no maximum here. They're all zero. In this case, I just picking one randomly. Picking one randomly, maybe I'm not going to go to the right as I did before. So when I'm starting the game, when I'm starting to learn the game, the step number one, we're just exploring. We're trying to, I might go to up and I would be wrong and I would have to go back. I go to the left, I would be back wrong, or I would go right straight to the first one. Oh, I can go there. What is the value? Let's say if I'm here, what's the value of the beginning? The beginning, from beginning going to the right, from here to here, what is the value? If I was successful going to this place, what is the value of this place? It's going to be the best one in the future, but I don't really know what the best even. I'm really in a hard time. In the very beginning, I really don't know. But one thing I do know. So if I'm randomly value here, again, what am I going to do? I'm going to take the best next step, but I don't really know what's going to be the next. So I'm going to take some randomly. So it's going to end up taking some zero. Multiply it by 0.9, and I'm going to add 3. So the value here is really 3 in the very first time. Everybody got it? So this is a little, how is really starting the whole process. Here I just kind of jumped right when I already have some values, which was easier to explain. But really in the beginning, we don't really know anything about this Q table. We have to fill it up. Taking some random actions. But as we becomes, and the table becomes, see, next time, I'm not going to, I'm not going to take randomly here. I always will make right because 3 is higher than all the other ones. That's when I have learned something. And that's the table will start building itself up and goes up and up. Let me go into look a little bit to the code. I hope this is, I spent the whole session today on talking about the Q table and it's worth it. It's hard. I talked about the Bellman equation and please go over it. Listen to the video even 10 times. Honestly, when I was a student, I did it. I went over it many times. Let me just open you to the code a little bit, and next time we'll dive more into it. And that one and one, this one. Okay, if you remember last time, I talked about the agent, I talked about the environment. Next time, okay, the reward, the environment will give me the reward for any actions I'm doing, and will tell me which is my next stage. What is my next state? So those two things the environment tells me. What does it mean? That if I am in here and I'm making a right, it will tell me your reward is such and such, and you are in this state. Those two things the environment tell me. Now, who is really taking the action? Another object of agent. And you will see in the agent, we have the Q table. You see this Q table? See that? And you will see that what it does two loops inside, meaning it's going over all the rows, over all the columns, and each one of them is putting 0 in all of them. That's what I meant, that when we're starting, we're putting everything as 0. And the one that actually does the work is like putting 0. It's this function, initializing the Q table. So the Q table, everything is 0 in the beginning. Then we will see, we'll go next time, we'll go how the agents take an action and how is the Q learning is, in another word, how is the Q table being updated? And that's really what we will see here. It will be updated. This is will be actually, we'll go over the code that does it. Then I mentioned the exploration. I didn't say the word exploitation. Exploitation is really using the value in the Q table. But the beginning will have exploration, okay? And we will go over that one, and that will be part of the choose function. Where is the choose function? Here we go. We say when the agent's making a decision, when the agents, where is the choose function? Here we go. This one. When the agent choose an action, the beginning, it takes a random action, and as they learn more and more, it starts making a more educated action. And we'll go over the code next time. Okay, guys? Thank you, guys. Any questions? Today was a little heavy. Okay, I hope that was useful. I hope. But take my word for it, it gets easier. When you go over it several times, it gets easier. If you try to skip, you never pass the required level of coping with the difficulty. And those concepts will go over them many times. Eventually, they will make sense. Okay, guys, any questions? I'll go over that again next time. It will